Okay, once again, the sigma is shown. That means we have to consider finding the sum, despite the fact that the question actually says find a sum. We have to decide whether it's arithmetic or geometric. Looking at this, we said before if it was arithmetic that that variable would have been with a coefficient in the expression. In this one, if to see if it's geometric, you'll see that the variable will be an exponent. The k is here, the variable. So this is definitely a geometric. And the rule for the geometric sequence we have to remember was previously given to you was here. So for this, we need to find the first term, the common ratio, and the number of terms here. Now, I can't emphasize how important it is to remember this when dealing with a sigma. If you want to find out how many terms you have, you're going to be taking your stop value, subtract from it the start value, then add 1. So that's easy. That's 16. Now, the next thing we have to find out is what is r? R is the base. So whatever is being raised to a power is r. So r is equal to 4. And we have to find out what's the first term. The first term is gotten by plugging in the start value. When you plug in 5 into k, you get this. Now, if you decide to write 5 minus 6 as opposed to negative 1, fine. But please make sure you put it in parentheses. Okay, so our first term is 3. Okay, ready to plug things in now. So we're going to get 3 parentheses 1 minus 4 to the power of 16. We're going to get a large number here, I'm pretty sure of it. Now, we got to watch out. There was this 2 here. What that 2 means is that we're going to be multiplying the entire value by 2. So first we're going to be doing is finding out the total value of that sum there, then multiply our answer by 2. So I'm going to find out the sum without multiplying by 2. Yeah, that's a large value. Now that's the summation without multiplying the whole thing by 2. So just take this value and get your answer. It's a very large number, but it's not a big deal if you use your calculator. The thing to watch out for this guy is this thing. When you have a coefficient out front of the whole sigma, just find a value of the sigma, then multiply it by 2. Okay, this is an infinite sequence. More specifically, it's an infinite geometric sequence. We do have the formula for this. It'll be given to you on a test. The thing to remember is that this is like a condition. Most cases, it will be right. We'll talk about when it's not less than 1. But the absolute value will more than likely, for tomorrow's test, it'll be less than 1. And we'll explore what happens if it's greater than 1 or equal to. Now, for this problem right here, like I said, the indication that was infinite was that symbol right there. We can see that this is a power, a base raised to a power, and that's why it's geometric. Now, for this problem, all we have to do is find out what r is equal to. R is equal to the base, in this case 1/3. And I need to find out what's my first term. You get your first term by plugging in the start value into the original. So 27 times 1/3 and 3 minus 1. Three is the first term. So now 3 is the first term. We're good. We can just plug this whole thing into this equation right there. So 3 divided by 1 minus 1/3. Using your calculator, You don't have to put the 1/3 in a parenthesis. Only if it were negative would you have to do something like that. And 4.5 is our answer. Now number 8 is an infinite sequence. The reason is they'll be indicating it with the dot dot dot. Now for the geometric sequence, you have to find out what is the r, what are you multiplying? Sometimes finding r isn't so obvious. So what we have to do is take the second term divided by the 1 before it. And you'll see that if we were to take the 8 divided by the 12, we get the same things. It's going to be 2 over 3, and so is this. But 2/3 is what your common ratio, or r, is equal to. So again, we're going to be using this formula. 18 is our first term, 1 minus our common ratio. It seems too easy, I know, but you know, sometimes this math isn't always that hard. I'm just checking. So 54 is the answer. Next question. We had to find the common difference. If you have an arithmetic sequence and you're given two terms not next to each other, it's a little more challenging to determine what the common difference is. So here's a generic formula that works for this particular problem, and it works for any problem that they give you any particular terms. So what I need to do is plug it in. So my 28th term is negative 15. My 16th term is 45. By the way, it said it's arithmetic sequence. That's why, and also looking for common difference. That's why we're doing this. So the common difference is equal to negative 5. Okay, next one. This is a geometric sequence. We're not finding a common difference, we're finding a common ratio called r. And here's a great example of how to find r given two particular terms using this problem. So for this problem, I'm going to get 8 minus 3, which is 5, and take the two terms there, that's 64, divided by 486. And to find r, I have to take the fifth root. Now remember what I said many times, that if you're going to be taking, if you had an even power here to start with, when you take the even root, you're going to have to deal with a plus or minus. But if it's an odd power and we take an odd root, it is what it is. So I'm just going to get my calculator. Get this. You can even convert this into a fraction if you wanted to. At this moment, it's not required. If you were to take the fifth root of this, you could clear this. You could do it this way. You press 5, you go to math, you press 5 again. That'll give you the fifth root. Now it's important. It doesn't put the parentheses in there. You have to do it yourself. That's 2/3. Not so bad.